Now, the radar can also give some estimates on how much rain's fallen itself. So this one is called a 1-hour precipitation estimate. So the color codes on here just give you an estimate how much rain has fallen in the last hour. All the usual radar problems that we talked about earlier, stuff close into the radar, odds are we're not going to see it. The zero velocity line going to screw up the product there as well. So we may see, this is an example from Slidell's radar, but there may be times where there's storms over the radar site and you're not going to see anything. In fact, if you look real closely, you can see where the radar site is right here. So there's a little hole right over the radar site. Storm total precipitation is another one. It can give you several hours, or if it's been raining for several days worth of rain totals as well. This is something that came in a couple years ago. We talked about this a little bit before. Conventional radar sends out a radar beam, one single radar beam. Now it sends out two, one horizontally, one vertically. And that dual pole radar actually helps us determine some other things on there. So let me just back up and go over a couple of them here. So differential reflectivity is a ratio of the reflectivity between these two pulses. So it's just going to be the ratio. So 1-to-1, it's seeing the same thing horizontally and vertically. And if you're seeing it differently, horizontally and vertically, it can give you an idea of what you're looking at. So if it's close to 1-to-1, it's going to tell you if the number gets larger than that, it's larger raindrops. If it gets smaller than that, smaller raindrops, because the raindrop, as it's falling, it's going to be elongated. Same thing with hail. The larger the number, more likely going to be rain. The smaller the number, going to be more likely larger hail. So kind of opposite of the rain perspective. And then same thing for snow perspective. So a wet snow versus a dry snow and whatnot. Another feature is correlation coefficient. It's a statistical correlation between the horizontal and vertical returns. And so same situation. It's a combination that we look at these values. How far they are away from one would indicate different size hail, different types of whether it's snow or not, and the size of the drop size. And the third one, specific differential phase, like I said, all sorts of technical mumbo jumbo here that odds are you're probably not going to be using it yourself, but hey, they're all available out there. Once again, these variations give you an idea of what you're looking at on the radar. And the last one on here that's kind of useful, hydrometeor classification. The radar gathers all this dual pole data and can determine what the heck is it looking at. Is it looking at rain? Is it looking at rain mixed with some sleet? Is it looking at rain mixed with snow? Is it looking at rain mixed with hail? Is it looking at mainly large hail? Is it looking at whatever? So, this is the Lake Charles radar. The further away from the radar beam is going higher and higher. So we're starting out looking at rain and these green blobs here. And now we're getting higher into the sky and we're looking at some kind of an ice crystal feature because we're looking so much higher in the sky. They also have a radar estimate of the precipitation as well. So I'll skip across that. Give a couple examples of some severe weather examples. This is a pulse severe thunderstorm at the Lake Charles radar. I drew this little white line on here. I'm doing a cross section of this blob to show you what it looks like here. So, close to the radar, I can't see anything. So now I can see a storm here, but once again, it's too close to the radar. This storm here may go up to 30,000, 40,000 feet, but it's so close to the radar I don't see it. The further out, I can see more of the storm and it goes higher in the air, but you can see all sorts of issues here. I'm not seeing things going on the radar high up above. But what we are looking at here is from the time sequence, watch what happens with this particular blob here. It moves closer to the radar beam, it's getting closer to the ground, and as it does that, it increases the wind. So here's the correlation with the wind speeds that we're looking at closer to the ground versus higher in the sky. You can see the wind speeds getting closer to the radar to indicate that. This is that same picture from earlier, the squall line, and the thin line out in front of it indicating the outflow boundary to indicate where the strong gusty winds are. This one here, the cross section of the squall line, it shows the tilt of the storm itself. So here's the example where it's raining probably on the ground all the way through here, but over here it's not raining, but yet right above it, 10,000 feet, there's super heavy rain right above it. So it's a tilted storm. We call this a bounded weak ecoregion, and so a lot of times this is going to be the location that we're focusing on for a severe storm. If the storm here, like in this picture here, the storm is moving from right to left, so we know that this big storm, this thing here is going to fall down to the ground as the storm is moving off to the left. Here's an example of one of the supercells over in Texas, or actually no, it's one of the Texas storms. So we're looking at the velocity picture here. The red's wind's blowing away from the radar, green's blowing towards the radar. A couple different examples here. You can even see the little bit of a weak echo region right here in the middle, corresponding to where the outbound and inbound wind velocities are basically gate to gate on us here. Another feature that the radar can do when it runs through hail, the radar beam itself gets confused when it's going through a block of ice. So it'll make what we call a three-body scatter. So like here's a block of ice that the radar beam is going through, and so it just shoots something out here. This is not reality, but because it gets confused, it adds an extra spike or spoke on the radar beam itself because it doesn't know what to do with it. Other non-weather things seen on the radar, this is just your typical ground clutter that you're going to see in the morning hours. Sometimes you can see things like smoke from fires. This is a hazmat accident over in the Beaumont, Port Arthur area that we saw the plume, and we can zoom in and overlay it with the streets and whatnot to tell people where the heaviest plume of this stuff is going. This is actually a neat one. This happens over here just as much as it does in southeast Texas. Birds, migrating birds, what they're doing in the morning, they've roosted somewhere, and then in the morning the sunrise comes and these birds are taking off. So it starts out, it looks like a big blob of rain, and this is not big. This is literally like a mile or two across. But it starts out with this little blob, it turns into a little ring, and the ring just gets bigger and bigger as the birds are getting up in the sky and spreading out. So we don't do a lot of studies of the bird migrations, but scientists interested in birds have done a lot of research using the radars all across the United States for that. Space Shuttle Columbia, when it was crashing on its way back into the atmosphere, the debris from the shuttle was seen with our weather radar. And so the weather service, our radar, Shreveport's radar, Fort Polk's radar was very useful to all the people that were in the recovery phase to determine where did all this debris land. A lot of people post pictures like this on social media saying this is alien attack, this is government conspiracy, whatever. What we're looking at here, this is in the northeast part of the United States, multiple radar sites, Albany, Boston, New York City, Portland, Maine, and you see the little beam sticking out of all these things. What happens is during sunrise and sunset, when the radar beam hits the sun, it gets blocked out. So it's going to be, you're going to see a funny looking thing on it twice a day. This one obviously is a sunset feature as it's looking to the west. In the morning there would have been one off to the east. And so this is something that if the radar beam, remember this is all being tilted up through the atmosphere, it has to be at the exact moment that the radars are actually looking at the sun at the same time. And it can happen, and like I said, people get kind of freaked out by it, but it's a normal atmospheric phenomenon that the radar is picking up on. Another kind of funny feature that we can pick up on with a radar, this is zoomed in on Lake Charles, so this is I-10 and this is the 210 bridge. We can actually see the wind speeds on here. They're not wind speeds, that's car speeds. We can see cars speeding over the 210 bridge because our radar beam goes perfectly right down the radial along the 210 bridge. So yeah, we can see people racing across the bridge. Once again, that is only going to happen when the radar beam's at the lowest elevation. So we're not seeing it continuously. So we don't have a law enforcement coming to the office saying, "Hey, what was that 626? What'd you have then?" There's nothing like that because we see these high speeds out here, but we don't obviously see a car associated with it or anything like that. But it is kind of funny for anywhere where the radar beam parallels the interstate. So this is the 210 bridge. This is just the east side of the 210 loop, and same thing. You can see spots where the cars are speeding along the interstate there. So kind of a funny feature. And that's for any weather radar in the United States. Shreveport, same thing, going down I-20 up there. The radar is very close to the interstate, so they can see people going up and down the interstate. So this was a little bit of a technical over our heads maybe at times, but that's the radar version of basic radar interpretation for, if you got an interest of using it on your smartphones or looking at it on the web pages and whatnot, or even just when you're watching TV, to give you an idea of what you're looking at when you're looking at the storms out there.
That radar scope application is great.
Yeah.
I did get it in amazing.
Yeah, radar scope is a very good one. You can pick a single radar site and tilt it through all the different elevations, and you're going to see all sorts of things.
It's amazing.
He was talking about some application, that's something he gets on his computer that can look at your information.
Radar scope is an app for a cell phone, and I don't know how much it costs, but there's a,
$9.99.
there's a $9.99. You know
Worth every penny.
you go on the whatever device you got to whatever store you have on your
You
thing.
can use it on
mine-
Amazon. I use it on my, well, he uses it on his Kindle, but you can use it on your phone, computer.
Amazon Kindle Fire. We got it on there.
What's the name of it?
It's called Radar Scope.
Take a picture of him or
All right. Well, thank you all for coming out tonight and listening to our presentations.
Well, thank you
Thank
for
you.
coming.
Thank you for coming.
Appreciate it.
Is everybody on this roster here?